This next problem involves a number of skills identifying primary or secondary or tertiary amines or alcohols, identifying functional groups, and chiral centers. So this first one, we're shown a picture of an amine. This looks like a neurotransmitter. The amine is in isoetheren derivative is. So we look for the amine, look for the N, and we want primary, secondary, or tertiary. So how many carbons are attached to the N? 1, 2. It's a secondary amine, and we can go on to the next part. What other functional groups are present in the isoetheren derivative? I would draw this out on my paper. The problem tells us it's a bronchodilator. This group here is like one found in the catecholamines that you learned about in one of your context videos. This benzene ring with the 2 alcohols attached. And then there are 2 carbons between the benzene ring and the nitrogen, so it's just like the catecholamines in that regard. All right, we've drawn them all. We can mark them with functional groups. We've got 3 alcohols. You could call these 2 phenol groups. But we've got 3 alcohols and 1 arene. And then we've got a couple of an ethyl group off the nitrogen, an ethyl side chain there. So let's check our list. We go down till we find hydroxyl groups. There are our alcohols, and we've got an aromatic ring, and that's all of it. Now we have it drawn again, and we're supposed to identify chiral centers. So I can go over to the paper and look for any place that there are 4 different things attached to a carbon. So we can rule out the benzene ring and all the oxygen. We can rule out carbons with 3 or 2 hydrogen on them. So we're down to 2 spots where there are possibilities. Each spot has 1 implied hydrogen. So this carbon on the right has a carbon, a nitrogen, a hydrogen, and a different carbon attached to it. So there's 1 chiral center. The one on the left has a hydrogen, a carbon, and an oxygen. The 2 carbons are different, so it's 4 different things. And we've got 2 chiral centers that we can mark. And we'll check that third part. We're all done.